So if we focus on our support for OSPF inside of NSX, we have a very functional OSPF support model. We support two types of areas. We support a normal area, and we also support a not-so-stubby area, an NSSA. Certainly, OSPF has options to support some more exotic areas, if you will, or other exotic options. These are typically not deployed in a data center and are more kind of prevalent in a WAN environment. So we wanted to be very focused on what we support from an NSX perspective and focus on normal areas and NSSAs because of the inherent benefit that NSSA brings by being able to just feed a default route or accept a default route and minimize the amount of LSA state that's stored inside of a router. So these made the most sense from a capabilities perspective and meets the needs of the vast majority of our customers. Certainly, with OSPF, there are different design rules that need to be taken into consideration, and those still apply with NSX. So you need to still have area consistency. So if you have an area 0 and subsequent areas that are connected to area 0, they need to have that connectivity. You can't have area 16 connected to area 17 without an area 0 in the middle, for example. And these are just traditional OSPF design rules, so nothing terribly surprising here, right? We need to maintain our area connectivity and adjacency requirements. LSA propagations for OSPF advertisements still works and behaves exactly the same because it is the industry standard protocol. We do support clear text and MD5 authentication to OSPF neighbors. So for customers who are looking at being able to support password connectivity between their OSPF peers, can also configure that in both clear text or MD5 for additional layers of security if so desired. And we also support graceful restart for OSPF, which is industry standard as well, negotiated between the OSPF router and the Edge Services Gateway. Finally, we support tunable routing protocols for both hello and dead timers, and this enables options for customers who want to tune or adjust these timers to change the convergence performance of the network. We default to industry standard default timers, but we also have the option to be able to support lower timers for tuning of the networks. So that is also an option as well. So let's take a look at how we configure OSPF inside of the NSX graphical user interface. So here we are in the NSX graphical user interface, and we'll start off with our home page. To configure our OSPF routing environment, we're going to go down to our NSX Edge, and we're going to go back to Perimeter 1. That's who we've been working with so far in the routing exercises. And we can see that our global configuration, OSPF is disabled. The only routing protocol we have enabled today is the Border Gateway Protocol, and that's it. So let's take a look at the routing configuration and see what that looks like on the Perimeter Gateway itself. So if I do a show IP route on the Perimeter Gateway, I can see that I have two directly connected networks on my uplink network, the 100.3 node, as well as a transit network, the 5 network, which is used for transit amongst the devices. So no OSPF configuration in place in this particular topology. So let's go ahead and enable OSPF. So we're going to go down to the OSPF configuration tab. We're going to edit it, and we're going to enable OSPF. We want graceful restart, and we want to enable default originate. So this allows OSPF to advertise a default route to its neighbors, and this is an optimization that's commonly deployed so that my neighbors can just learn the default without having to have a default route configured on them. They can learn it through me. So we're going to publish our changes, and we're not done yet. We still need to configure our areas and interface mappings, but we'll begin by configuring our OSPF area, and we'll configure area 0. We're going to configure it as a normal area. I did mention that we can support NSSA, so that option would be selected here if we wanted to configure NSSA. But in this environment, we want to configure normal, no authentication, and we don't need to set any values. So, because we're not setting authentication, we again will publish our changes. And if we're interested, we can go back over to the Perimeter Gateway and do a show IP route, and we'll see that we still don't have any configuration here, right? So nothing has happened. We've started the process, we've enabled it, but we haven't actually configured OSPF to do anything meaningful yet. What we're going to do next is enable OSPF on our interfaces. So we're going to enable it on our transit network in area 0. And these are our default timers. 10 seconds for hello. Dead interval is 40 seconds, which is the hello interval times 3 plus 10. And then our default priority and our default cost. And if we scroll down, we can see the interface mapping. We'll publish our changes, and we can now see that we have the transit network in area 0, and like we are in good shape. So now let's take a look at what that shows up in our router over here. And now we can see that since we've enabled OSPF, we're now forming OSPF adjacencies with our other devices on the network, right? So if we do a show IP OSPF neighbor, we can see that we are talking to another OSPF-enabled router on VNIC 1, that we've established a full adjacency and designated router status. So we've got a traditional OSPF configuration. Now we're learning these routes from another router and populating a route table based on that. So very simple to configure OSPF, and not a lot of heavy lifting that needs to be done to configure various options. You can see that almost everything is done either in the area definition page that we looked at earlier, where we can specify our authentication and the value for the authentication. Right, we can specify password, which is clear text, or MD5, and then also we can specify our area to interface mapping. So this is a pretty simple configuration to accomplish, and with that, we've configured OSPF. So how easy is that, guys?